guys. Not that long ago we talked a little bit about circles, and then we went into trigonometric functions, and we talked about figuring out how tall a tree is, because we're talking about sustainable forestry, so we need to know about trees. Well, now we're switching back to the circles, and you'll see this whole thing will come together. Let me grab this circle, bring it out here, make them bigger, bam! And then I'm going to draw a diameter in them. That looks to be about the middle, right? Let's do that. So, the diameter, the length across the center of the circle, and we want the area of this circle, which we had talked about before. The area was pi r squared, right? And the radius, right there. If this was 3 centimeters, then it would be pi times 3 squared, which would then be pi times 9, because squared means 3 times 3. And then pi times 9, we can use 3.14. Or if you're using a calculator, you can just hit the pi button and it will be more exact. But I'm okay if you use 3.14 times 9, and we get approximately 28.26 centimeters squared. So the area of this circle is about 28.26 centimeters squared. So what would happen if we had a circle like this guy, and we figured out his area, and then we took another one and we put him right on top. Boom. We took another one and we put him right on top. Boom. And we took another one and we put him right on top. Boom. Oop, you son of a gun. Boom. Eventually, you keep putting these guys directly on top of each other, it's going to end up looking like a Campbell soup can. Something like that, right? That is called a cylinder. There are two things we can figure out about a cylinder. The area of a cylinder, which is all of the outside, the top of the can, the bottom of the can, and all of the middle of the can, the whole outside. That's the area. Right now we're not worried about the area of the cylinder. Erase. That doesn't want to erase. It'll erase that though. Lame. All right. Undo. Okay, so I know that looks more like a slinky than a cylinder because I couldn't stack them up just right, but you know what I'm talking about. The area of the cylinder is not something we're going to worry about right now. Don't carry an area. Right now we're going to talk about the volume of a cylinder. The volume is the inside, the amount of liquid in that Campbell soup can. That's the volume. And it turns out it's fairly simple to figure out, because if I have this circle and I just make it go higher till I get to the very top with my terrible handwriting, that's your can, that's your cylinder, right? So if we take the area of the circle and multiply it by how tall the circle is, we get pi r squared h for height. And that gives you the volume, because the area is the entire inside of this circle, right? And you take the entire inside of that circle, stack in tiny little slices, that's your volume. I hope that makes sense to you guys. That's the best way I can explain that. So the volume of our circle is pi r squared h. And erase that. So volume equals pi r squared h. And this is of a cylinder. Okay, so that's a cylinder. What if we have a cone? So say we have this circle, and instead of stacking stuff up on it over and over again to make our cylinder, we stack up tinier and tinier ones on it over and over again until we get our cone. Just like cones on the street, whatever, a cone, right? And that's really horrible drawing, but that's okay. Turns out, if you take this guy up here and you make your cylinder, that this is 1/3, this is 1/3, and this is 1/3 of the cylinder. So the volume of a cylinder, or sorry, of a cone, 1/3 pi r squared height. That's of a cone. So the circle makes sense because it's just the area and how tall that area is. The cone makes sense because there are 3/3 to that cone, or to that cylinder, and 1/3 of it is the cone itself. And this is for a right circular cone. If you want the math term, it's a right circular cone. All that means is it's straight up and down. So if you draw a line right here, you would get a right angle right here, 90 degrees. Right? It's right, and it's a circle. So you could make a cone that's more cylinder shaped, right? And less circle. You could make one, I don't know, whatever. But this is a right cylinder cone, a right circular cone. So those seem like things that are pretty easy to remember. And 1/3, what you also what you often see with this guy here is they take it and they try to trick you, and they'll say things like volume equals pi r squared h over 3. Or they'll say volume equals pi r squared h over 3. Or some other silly nonsense. Just remember, if you multiply 1/3 by these, you're going to end up looking like 1/3, so you have to turn the other ones into a fraction. Pi as a fraction is pi over 1. R squared as a fraction is r squared over 1. H as a fraction is h over 1. So if I multiply 1/3 and h, it becomes h over 3. 1 times h is h, right? Pi over 3, r squared over 3, pi r squared h over 3. It all means the same thing. They just like to write it in fancy ways. The most common ways that I personally have seen it, though, is 1/3 pi r squared h, which I like because it just makes sense. And then there's pi r squared h over 3, which is the same thing, only written by someone that wanted to feel smarter or something, or I don't know, show off. Doesn't matter. Hopefully, both of those things make sense to you, because the next thing I want to talk about is called a frustum. Frustum? And that's a weird thing, but it's basically take a circle, you take a bigger circle. So it's a cone if you chopped it off right here. Right? Just chop the top off a cone. That's exactly what it is. So we're talking about a right circular cone, like we were just talking about, only we lop the top off. So instead of having a point, it ends there. Now this one, we get volume equals 1/3 pi h, which, remember, our cylinder, or let's go with our cone, 1/3 pi r squared h, right? So we still have the pi h, but instead of r squared, because it changes, we're going to have a rather confusing thing. We're going to have, and I don't like the way they did that, so I'm going to do it the way I'm used to it. I'm going to erase that. We're going to have R2 plus R2 times R1 plus R1 squared. Now what does that mean? Well, R2 is this top one, so the radius of this circle, and R1 is the radius of this circle. So basically we're getting, I guess you could say it's the average, because it changes as it goes up, right? So we're getting the R2, which is this top one, and we're getting the R1, which is this one. Then we're also multiplying the two together. So if we had this as 6 centimeters and this as 3 centimeters, and the height was 5 centimeters, it would be 1/3 pi times 5 times R2 plus, times 3 plus 6 times 3 plus 3, so it's 3 squared, which is going to be 9. Okay, so that becomes 3 plus 6 times 3 is 18 plus 9. 21 plus 9 is 30. Okay. So it's going to be 1/3 pi 5 30. Well, 1/3 of 30 is 10. So I'm just going to get rid of that and get rid of that. Pi times 5 times 10 equals pi times 50. And we'll do 3.14 times 50. And we get a volume of 157 centimeters cubed. So this is a frustum.